In the name of Almighty God, I'm Mahsa Sankashi, and today I want to talk about detecting loss of excitation condition of synchronous generator in the presence of UPFC, which stands for Unified Power Flow Controller. Based on data mining method, here we selected unsupervised algorithm, so-called self-organized map. There are two possibilities to perform simulation. First is to build UPFC facts by the aid of Rx solution. We can compute time lapse. The second one is to compute loss of excitation by the aid of self-organized mapped or SOM from linear vector quantization or LVQ. We specify grid parameters as nominal system frequency, nominal voltage, short circuit level. Then we set shunt converter parameters as nominal PC link power. We have used a three-phases generator with Rx, which stands for resistance and inductance. And its model is synchronous machine, and we can specify in load flow of generator as swing. We can right click on the subsystem of three-phase generator and select the load flow tab, and finally specify swing for synchronous machine. And we need to give a value for phase angle based on degree. Otherwise, we had to define active power for both minimum and maximum. The simulation compute loss of excitation event for a stator current, and the SOM or self-organized mapped algorithm has been written in FCN block. Inside its code, the steps for feature extraction and neural network architecture has been defined, for example, the layers and learning rate values. And due to this method is determined for anomaly detection, therefore the best features would be selected, and finally the outputs will be moved to LVQ or linear vector quantization, and it can categorize our vectors properly based on quantization, which means it works on quantifying vectors. After simulation and time passed, we can go through UPFC or power measurement or control set subsystem and check plug and value in display scope as rectifier control and voltage. For example, now you can go through UPFC subsystem. The compilation has been finished. And now the time is passing. Now it's time to go through the subsystems. For example, here in power measurement, and see the each scopes that has been defined here.